Ultimately, big data technologies allow us to store and process these massive amounts of data and storage processing capabilities that artificial intelligence needs in order to function. Essentially, big data technologies act as a brain for artificial intelligence. But we still need a mind in order for AI to think, which leads us to our next topic, machine learning. Machine learning is a subfield of artificial intelligence based on statistics. It involves machines learning how to solve problems without explicitly being programmed to do so. Essentially, with machine learning, we use existing data in order to learn a function that can make a prediction given new data. For example, imagine we want to create a function that determines whether an image contains a picture of a cat or not. First, we'd have to create a data set of images with cats and without cats. We'd have a human being label each of these images, indicating whether they contain a cat or not. Next, we would apply a machine learning algorithm to the data set of images with and without cats so that it could learn what catness is. Essentially, what is it about the image that indicates there's a cat in it? The algorithm would then learn a function that we could use to predict whether an image contains a picture of a cat or not. Finally, if we've done everything correctly, we should be able to feed this function a new image, and it should tell us if it contains a cat. And now, while this is a vastly oversimplified explanation of machine learning, it essentially captures the essence of what we're attempting to accomplish. Some of the tasks that machine learning are really good at are things like classification, where we make a prediction or a decision based on two or more categories or outcomes. Regression, where we attempt to predict a numeric outcome based on a set of input variables. Clustering, where we group objects together based on similarities in their data. And anomaly detection, where we find data or observations that are different from the normal data. But that's just the beginning. In addition to using machine learning on tabular data, we can also use it on a variety of inputs, including text, images, audio, and video, and a variety of outputs as well, which has led to some pretty cool inventions in the recent years. For example, we can now perform object classification, video segmentation, and motion detection in real time. But we can also generate synthetic output as well. In fact, the following imaginary celebrities were generated by an artificial celebrity generator trained on 200,000 images of real celebrities. Not a single one of these images is of a real person. Every one of them is synthetic. In fact, we can watch the algorithm as it learns how to construct new celebrity images over time. And as we can see with each training step, the algorithm gets progressively better at generating new celebrities. And check this out. The following video was produced by a lip-reading deep learning algorithm. Essentially, it was trained based on existing videos, but all 4 of these videos you're about to see are completely synthetic. They are not real.
To help families refinance their homes, to invest in things like high-tech manufacturing, clean energy, and the infrastructure that creates good new jobs.
You can imagine how scary this technology is going to be if we don't get control of this or get it in the right hands. On a lighter note, though, deep learning algorithms are currently being used to teach artificial bodies how to walk. And once you can get a virtual body to walk in a computer simulation, it's not a very far stretch to get it to walk in the real world. And I should probably point out that these are relatively early in the training samples. Like this thing now probably walks better than I do. You can throw a boulder at it and it won't even knock it over. And speaking of machines being better than humans at certain tasks, modern machine learning algorithms are now better than humans at many tasks that you might not realize. For example, most board games, 8-bit video games, and card games like poker. Communication tasks like speech recognition, language translation, and even lip reading. And various medical tasks like diagnosing certain diseases, recommending prescriptions, and creating tailored treatment programs for each individual patient based upon their genetic profile. And machine learning is getting better at new tasks every day. However, while machine learning might be really good at some tasks, there are certain tasks that it's not so good at. For example, trying to determine whether a picture contains an image of a mop or a picture of a dog. And this might make sense because some dogs look like mops, and some mops look like dogs. But it's not just dogs and mops that they confuse. They also confuse other categories of dogs and things, like beagles and bagels, or chihuahuas and muffins. And you might be thinking to yourself, well, we can fix that. We'll just tune the dog detection algorithms to only see dogs, right? Yes, we can. And this is what you get. This is a machine learning algorithm tuned to detect only dogs. So as it's going through this grocery store, essentially everything it sees is some kind of dog. This algorithm literally is hallucinating dogs right now. That's super trippy. Machine learning gives artificial intelligence the ability to detect patterns, to make decisions, and to predict outcomes just like human beings do. Essentially, machine learning is the mind for artificial intelligence. But we still need one more thing. It needs to be brought to life, which leads us to our final topic, closing the loop. So how will artificial intelligence affect you, your career, and our world? In order to answer this question, I think the best way is to explain where this is all going and the future of artificial intelligence by closing the loop. Here's what I mean. First, we start with the Internet of Things, the physical body of artificial intelligence, a peripheral nervous system of devices and sensors generating massive streams of real-time data about the world around us. Second, we have big data, the brain for artificial intelligence, or big data technologies, the brain for artificial intelligence, a central nervous system of elastic and scalable distributed computing with the ability to store and process these massive data sets in real time. Third, we have machine learning, the mind for artificial intelligence, software with the ability to detect patterns, to make predictions, and to make decisions and predict outcomes using IoT data and running on this big data infrastructure. Finally, we close this loop by allowing the machine learning applications to execute commands in the Internet of Things. This allows the devices to affect the world around them. Then, they sense the results of their actions to determine whether they produce positive or negative outcomes, feed that data back through their model to learn from their results, and they learn how to optimize their behavior over time. Closing the loop completely eliminates the human in the middle and leads to fully autonomous, intelligent systems capable of making rational decisions and learning how to optimize over time. Over the next few decades, we're going to see the emergence of many of these new fully autonomous systems, which we are starting to refer to as smart systems, cloud robotics, cyber-physical systems, or simply artificial intelligence. For example, we're going to have self-driving cars relatively soon that will replace every human driver on the planet in automobiles, semis, boats, and airplanes. We'll have smart buildings that can optimize their own energy efficiency and anticipate the needs of their occupants. We'll have general-purpose robots that will be able to perform manual labor without being explicitly programmed to do so. And we'll eventually have smart cities that will optimize municipal resources like electricity, water, waste, and traffic, once again without any human intervention. We'll embed artificial intelligence into all aspects of our environment. Essentially, computers will become invisible as artificial intelligence will just be woven into the fabric of our society. And this is going to have a pretty significant impact on our economy and capitalism as we know it. First, it looks like this will likely lead to a much more nonlinear economy. Those that have these smart machines will have even more power, and those without smart machines will have even less power. In addition, data will likely become one of the most valuable resources in our information economy. Those that have the most data and the ability to enable artificial intelligence with that data will wield tremendous power in our information economy. This will also have an enormous impact on our labor economy. AI will eventually replace all human labor at some point in time in the future. The economics driving this say it's not a matter of if, it's just a matter of when this will happen for each job. In fact, some experts are currently attempting to predict which jobs will be eliminated based upon their repetitiveness and complexity. We can even attempt to predict what type of artificial intelligence technology will be necessary to automate a wide variety of occupational tasks. For example, we can see which retail jobs will be likely to be eliminated in the coming years as artificial intelligence continues to be applied to retail sales. Even the medical industry isn't immune to this coming wave of automation. While these medical tasks are generally considered more complex and less repetitive, they're rapidly becoming within the reach of artificial intelligence. As a result, we'll likely see a rapid increase in the number of machines performing manual labor and knowledge work that was once the job of humans. The rate of industrial robots has been growing steadily over the past few decades. However, with the application of modern artificial intelligence, it will likely only amplify this trend. I'm anticipating we're just seeing the beginning of a very sharp hockey stick happening, like we've seen with our previous technologies we looked at. We're beginning to transition from a world or an economy where most of the work of value was done by humans to one where most of the work of value will be done by machines. As a result, I think it's very important that you ask yourself this question. Which side of this new economy will your job be on? The side that's leading this new economy, or the side that's being eliminated? Well, I, for one, welcome our new robot overlords. In fact, I'm learning how to speak binary as we speak so that I can be of better service to them in their never-ending conquest for global domination. Don't worry, the robots can't read reCAPTCHA yet. It'll still take a couple more years. In conclusion, today we learned three very important things. We learned what artificial intelligence is, we learned why it has become so important, and we learned how it will impact you, your career, and our world. I believe we're just beginning to see the true potential of artificial intelligence. AI is going to have a fundamental and profound impact on our world, on software, and on the IT industry for many years to come. So, to end, I'd like to propose three new questions to you. Are you prepared for this? Is your organization prepared for this? And is our world prepared for this? If you, your team, or your organization would like help preparing for the coming AI revolution, please reach out to me. I would love to help. Thank you very much.